Hi students, today we are going to be modeling the combustion of ethanol. So I'm going to be taking notes in my notebook and I've turned it sideways, and then I'm also going to be using this molecular model kit. So we are going to be building this together and we're going to take some notes while we go. So first things first is we need to know what ethanol is made of. And ethanol has a chemical formula of C2H5OH. You could also write this C2H6O, but I like to write it this way because this tells me a little bit about how the molecule is structured. So this tells me that there are two carbons. And when I'm drawing these out, carbon really likes to bond to itself. So I'm going to draw a carbon, and I'm going to draw that carbon bonded to another carbon. All right, now that I've got my carbons, I know that there is an OH, so I'm going to draw that. OH is an oxygen bonded to a hydrogen. Well, let's make the hydrogen come down here. And oxygen has these two pairs of electrons that stick off of it. So I'm just going to draw those there just so that I know that they're there. You don't have to draw them, but you can. It can be useful. And now I've got 5 more hydrogens. So carbon makes 4 bonds and hydrogen makes 1 bond. So each of these carbons is going to need to have 4 bonds. So this carbon has 1, 2, 3, 4 bonds. And this carbon is also going to need to have 4 bonds. And then that is the structure of my ethanol. Now I'm going to go through and build this, but before I do, I want to make sure that I know what color each of these things is so that I can build it out of the right atoms in my molecular model kit. So carbon is black, and whenever you use a molecular model kit, carbon is always going to be the black atoms that are in there. And that's just going to be helpful for you to remember. Oxygen is red. And then hydrogen is white. And I don't know how to draw white, so I'm just going to leave it as is on my page. So if I empty out my model kit here, I'm going to connect my carbon to another carbon, and then I'm going to connect it to an oxygen. That oxygen is connected to a hydrogen. And then my carbons, this one that's in the middle here between the oxygen and the carbon, has 2 hydrogens off of it. So there's one, and here's the other. Okay, now this one on the end has 3 hydrogens going off of it. So here's 1, 2, 3. Oh, come on. All right. And I like to arrange this so that it looks like, let's see if I can get this to twist. I think it looks kind of like a dog. And so I call this Sparky the dog. So this is my ethanol. I've got my ethanol situated here. And ethanol has high energy carbon to carbon and carbon to hydrogen bonds. So the way that I'm going to represent that in my molecule here is I'm going to use yellow to color the high energy carbon to carbon and carbon to hydrogen bonds. Now, I'm going to represent that in my model by taking my yellow pipe cleaners, and any high energy carbon to carbon or carbon to hydrogen bond is going to get a yellow pipe cleaner tied around it so that we can keep track of which bonds have that high chemical energy and which ones don't. And that's going to be important because we know that while atoms are not created or destroyed, energy also isn't created or destroyed. So everything has to be kept track of. We need to keep track of our matter and we need to keep track of our energy. There we go. Take a look at yours. Make sure you've got it. Let's take a little note here. Energy is stored in carbon to carbon and carbon to hydrogen bonds. And then I'm just going to draw a little like arrow here. Whoop, like that one. Okay, so now we have our ethanol, and we know that our ethanol burns, and when our ethanol burns, we get something else going into the flame. And the something else going into the flame is what I have left over out of my kit. So if you remember, red is representing oxygen. So I've got oxygen that's also going to go into this flame. So oxygen looks like this. It's an oxygen that I'm going to color in red. And oxygen has to form two bonds. So it's going to form two bonds with another oxygen in order to make O2. And then if we're being really fancy, we can keep track of the fact that it also has, each oxygen has these two pairs of electrons sticking off of it like that. So I'm going to make an oxygen. So my oxygen is going to look like that. So go ahead and make the rest of your oxygen and then draw them into your diagram. So as you can see, I've made 3 oxygen molecules. So I'm going to draw 3 oxygen molecules. Oxygen, which is O2. All right, so I've got my model of my ethanol and I've got my oxygen. And when this chemical reaction happens, the bonds between the atoms are going to break and they're going to reform into new molecules. So the atoms are going to rearrange into new molecules. And we know that they're going to rearrange into molecules of carbon dioxide, which is CO2, and they're going to rearrange into water, which is H2O. So what I want you to do is I want you to take apart your molecule and I want you to make new molecules of carbon dioxide and water. I'm going to show you what those look like so that you can make them correctly. A water molecule is 1 oxygen bonded to 2 hydrogens, and a carbon dioxide molecule is going to be 1 carbon double bonded to an oxygen. Remember that oxygen has to form 2 bonds. And then double bonded to another oxygen. And that makes it so that each oxygen has its 2 bonds and carbon has its 4 bonds. So if I color this in so that we know what we're building, I'm going to have my carbon atom, which is black, my oxygen atoms, which are red, my oxygen, which is red, and my hydrogens, which are white. So let's build. Remember that all of the atoms on this side of the equation have to be on this side of the equation because atoms cannot be created or destroyed. So I'm going to make as many carbon dioxide and as many oxygen as or water as I can. So as many carbon dioxide as I can and as many water as I can using these atoms from my ethanol and from my oxygen. So here is water molecule. It looks kind of like that. My carbon dioxide. It should look a lot like that. So keep building until you've used all of your atoms. Okay, how many did you make? So I have 2 carbon dioxide and 3 water molecules. So I'm going to add those now to my diagram. I've already started with 1 of each, but now I need to add the rest. So I need to add another carbon dioxide. And I need 2 more water molecules. Let's do a little bit more labeling here. So this reaction is called a combustion reaction. And combustion reactions take something that has those high energy carbon, carbon, and carbon to hydrogen bonds, and it rearranges the atoms with oxygen in order to create carbon dioxide and water. So this type of reaction is called a combustion reaction. And when we're tracing our matter and our energy, it's important that we make sure that we have the same number of atoms on each side of the equation. So this side of the equation is called my reactants. And I've got C2H5OH plus 3O2. And those are going to rearrange into 2 CO2 and 3 water molecules, 3H2O. This side is called my products. And we know that we had the exact same number of atoms on this side as on this side because we used all of the atoms in our modeling. But what about this energy? We had this energy in our high energy carbon to carbon and carbon to hydrogen bonds. So let's make sure that we've taken care of the energy as well. The energy also has to be on this side of the equation. But do I have any high energy carbon to carbon or carbon to hydrogen bonds? Do I need to add these to any of the bonds in my molecules? Well, I don't have any carbon to carbon bonds, and I don't have any carbon to hydrogen bonds in carbon dioxide. And water doesn't have any carbon, so there can't possibly be any carbon to carbon or carbon to hydrogen bonds in the water as well. So it turns out that we still have this energy. This energy has to still exist. It cannot be created or destroyed, but it's going to be released. It's no longer chemical energy in this bonds. Now it's energy that's been released into the environment as heat and light. And I'm gonna put this like cartoon thing around this here, and I'm gonna color it yellow to show that anything that I had on one side of the equation, I also have to have on the other side of the equation, because it's really important that we make sure that matter and energy are not being destroyed. The matter can go from molecules to other types of molecules, and the energy must go from energy to other types of energy. So there we go. This is a combustion reaction.